this lesson on the power of powers property of exponents. Okay, let's consider some things that we've seen before. Like if we have x times x times x, a total of 44 times. Well, of course, that's x to the 44th power. We've done enough exponent properties already. That seems second nature to us. But let's just group them a little bit here. So if there was x squared times x squared times x squared, and there was 22 of them, how many x's are there in total? Well, if I were to split each x squared back up into x times x, do it all the way out, well, that's how many? We can write it as x squared to the 22nd, but we know there are, in fact, 44 x's there. Interesting. Making observations, looking for patterns. X to the second to the 22nd is x to the 44th. All right, let's check out this next example. X to the 5th times x to the 5th times x to the 5th, 18 times. Well, each of those is 5 x's. I do not want to try to write all of these x's. We could rewrite this as x to the 5th, and since there are 18 of those, it's to the, not 17. Let's change that back to an 18 there. Wait for it. There it is. Lost my brain for a second. Okay, so if there are 5 x's and there's 18 groups of those 5 x's, then we really have a total of 90 x's. Whoa. Did you see the pattern there yet? Let's look at another example just to drive it home. If we have x times x times x 22 times, that's x to the 22nd, of course, x to the 22nd. We keep going, and we have each of those x to the 22nds 8 times. Well, that's x to the 22nd to the 8th. Well, we would have 22 groups, or 8 groups of 22, and so that's really going to be x to the 176th power. Wow, that is a lot of x's. Okay, if you haven't made the rule yet, let's go ahead and do this. If it's x to the m, also to the n, that means there's m groups of n x's. Oh, geez. Or x to the m times n. All right, let's actually go ahead and apply this to some examples. All right, 5 to the 4th to the 3rd, that's going to be 5 to the 12th. We multiply those exponents. Done. 3 to the 9th to the 7th, okay, well, that's going to be 3 to the 63rd. Multiply those exponents. What about with a negative exponent? Hey, it still works. X to the 8 to the negative 5. Well, multiply those, and we'll get x to the negative 40. Oh, we can't leave negative exponents, though. We've learned that already. So we'll just rewrite it as 1 over x to the positive 40. Looks so much better, and we are done. All right, keeps getting more exciting down here. 5 to the 4 to the 3rd. Well, that's going to be 5 to the 12th. And on the bottom, we've got 5 to the 2nd to the 6th, so 2 times 6. 5 to the 12th. Whoa! If we apply the quotient property, 12 minus 12 for those exponents would make this 5 to the 12 minus 12 is 0. Hey, anything to the 0 power is just 1. And you might have recognized, oh, we have the same thing in numerator denominator. Yeah, that's going to be 1. Terrific. All right, let's look at another fun example. Let's go ahead and look at this one where a student made a mistake. Very common mistake. 5 to the 4th to the 3rd, and they said 5 to the 7th. Well, what did they do wrong? Well, yes, 4 plus 3 does equal 7, but that's not what you're supposed to do. They added the exponents instead of multiplying them like they should have. There is an instance where we do add exponents. When do we do that? We do that when it would be something like 5 to the 4th power times 5 to the 3rd power. Here we have two things with the same base. We add their exponents, make that 5 to the 7th power. What about here? 5 to the 4th to the 3rd equals 5 to the 64th. You might not even see what they did here, but if you think about it, 4 to the 3rd power is 64, so that's what they did. they did 4 to the third equals 64 instead of doing 4 times 3. So they did the exponents of each other instead of multiplying those exponents by each other. We're going to talk a little bit more about what they did and if that's ever something that happens where we do exponents of exponents like that. Okay. Let's look at this example. 5 to the 4th to the 3rd. This might seem like where on earth were they going, and hopefully you never make this mistakes, but they actually did 5 times 4. They got like into this thing that we need to multiply something, but they multiplied the 5 and the 4 instead of the 4 and the 3. Yeah, that's a goof for sure. We definitely don't want to do that. So they multiplied the base by the exponent. Don't want to do that. All right, following up on number 8, let's look at an example of the difference between 5 to the 4th in parentheses to the 3rd versus just 5 to the 4th to the 3rd. Kind of this staircase of exponents here. Well, if it's 5 to the 4th to the 3rd, that means it's 5 to the 4th times 5 to the 4th times 5 to the 4th, 3 times. It's, yes, that to the 3rd power means 3 times. So we really have 12 5s all multiplied by each other, which is why this is 5 to the 12th. But over here, that's not what it's saying. It's not saying to take 5 to the 4th 3 times. It is exponents of exponents, and so when you don't see parentheses like that, this time you do 4 to the 3rd power, and you get that 64. And so this is 5 to the 64th power. So be ready for that difference. So if we look at the example of 2 to the 2nd to the 10th, there's no parentheses here, so we do 2 to the 10th, which is 1024, and 2 to the 1024, whew, that's a huge number. That could fill some volumes there. All right, let's move on, and let's try another one. This next one looks like a lot of fun. X to the 2nd to the 3 to the 4th. Okay, well, we've got this 3 to the 4th on the outside there, and that is an instance where we need to apply the exponents doing 3 to the 4th to give us 64. So we've got an x to the 2nd inside, and we've got this is now going to be the 60. Oh, I'm sorry, I said 64. That would be 4 to the 3rd. This is 3 to the 4th, which is 81. So now we can multiply these exponents. 2 times 81 is going to give us x to the 162nd power. Lots of fun. All right, here we have another example. Here, the opportunity to do something is first here with this 2 to the 4th power. 2 to the 4th power is 16, so we have x to the 16th. And that is still raised to the 5th. Now, these exponents are across that parentheses, so now we're going to multiply those together. 5 times 16 is 80, so we have x to the 80th power. Wonderful. Okay, let's look at some additional examples. In these next examples, we're going to be writing things with only prime bases. So right now, the base of this number is 25. We want it to be a prime number. 25, not prime. It's a composite. So if we just look at the base itself for a second, 25. Well, 25 is 5 times 5, or 5 squared. So if we replace it as 5 squared, we can stick that there first, but we still have this exponent of 5 on the outside. Hey, this looks like a power of powers property example. So we can go ahead and apply that, and it says, of course, we're going to multiply that exponent of 2 times that exponent of 5, and we'll get 5 to the 10th power. Hey, prime base and an exponent. That's what we were looking for. That one is done. Terrific. All right, 81 to the 3rd. 81, also not prime. If you didn't recognize the prime power that gets us to 81, you might have momentarily saw this as 9 squared. Now, 9 is not prime. 9 is a composite number. So you could have jotted down 9 to the 2nd, though, and been like, okay, that gets me somewhere. But 9 is really 3 squared, and so that's 3 squared squared. And then you could apply the power of properties rule and make that 3 to the 4th. But hopefully you just recognize that 81 is 3 to the 4th. We still have that 3 on the outside, so we multiply the exponent of 4 and 3 together to give us 3 to the 12th power. Pretty big number. That's our answer. Let's look at 16 to the 9th. And again, you might see 4 squared, but hopefully you also see that's 2 to the 4th power to the 9th power. So we're going to multiply the 4 and the 9 to give us 2 to the 36th power. And we are done. Terrific. What happens if we have a negative exponent? Well, let's just sit tight on the negative exponent for a moment, and let's handle this 49, which is 7 squared, to the negative 5th. And we can multiply those exponents using our powers property, and we get 7 to the negative 10, or 1 over 7 to the 10. Terrific. All right, let's look at these. I love these examples where we've got m in the exponent. We're trying to find the value. So the exponents here, m and 3, well, they would be multiplied by each other if we apply our new property. And when we multiply them together, it's going to have to equal the exponent on the other side, so 3m must be equal to 21. Hey, a little simple equation, divide by 3, m must be 7. Yay! All right, that one wasn't too bad. Let's check out this one. You can already tell it looks like a lot more fun. All right, power of powers property right there. So we're going to multiply 4 times 3m is 12m. And on the other side, that's going to have to be equal to 3m plus 27. Hey, variables on both sides equation. Time to solve. Let's get all the variables partying on the same side. Let's subtract 3m from both sides. 9m is equal to 27. Hey, let's divide both sides by 9, and m is equal to 3. If you saw that m was equal to 3 from just looking at this, good for you. You're amazing. But I like doing the equations to make sure that we didn't make any goofs. All right. Let's look at how the power of powers property might look in some slightly different situations when we have multiple variables happening here. All right, so if we had xy times xy times xy times xy 44 times, well, we could think about, that's an xy and it's a quantity all raised to the 44th power. But we could have also remembered that multiplication is commutative, which means we can multiply in any order. How fun is that? So we could have written this as all the x factors first, x times x times x times x times x, and we could have had this 44 times, and then we could put all the y's, y times y times y times y, also 44 times. Hey, if we have 44 products of x, that's x to the 44th, and 44 products of y, that's y to the 44th. Whew. Hey, that's kind of interesting. We had xy to the 44th, or x to the 44th, y to the 44th. Whew. All right, well, it gets more fun if we have x squared, y squared, and we have that 22 times. Again, we could think about how we could regroup this. We could put all of the x squareds first, and there'd be 22 of those, and each of those x squareds is really x times x. So we have 22 x squareds, or 44 x's again. And the same thing's going to happen with our y's. So many y's. Hey, x to the 44th, y to the 44th again. Hey, hopefully you're seeing some patterns here. But let's look at one more example. X times y 22 times, x times y times x times y 22 times. And we have that all 8 times. So that's xy to the 22nd. And then that all is to the 8th. Whew. All right, so if we really think about just straight up how many x's there are, well, we can think about there being 22 groups of 8, or 176, and the same thing for y. So this is x to the 176, y to the 176. What madness is happening here? Hopefully you kind of recognize that this 8 is kind of distributing to this exponent in here. We were multiplying that, but then it applied to both things inside, just like this 44 applied to both the x and the y. Whoa, it's like distributive property for exponents. So much fun. Get excited. All right, let's break this down into a rule. X to the n, y to the m, all to the k. This k outside is going to multiply by both exponents inside, and we'll get x to the nk, y to the mk. Okay, right? That makes sense? Oh, that was a really bad joke. Oh, I feel bad for everyone who had to listen to that. All right. Hey, guess what? We also get to apply this when we have a quotient. So if k is out here as the exponent of this quotient, we can distribute it to both numerator and denominator. So we get x to the nk in the numerator, y to the mk in the denominator. Hey, that was awesome. Hey, let's apply this to some of our examples here down below. X to the third y to the negative ninth to the fourth power. We can take this fourth power outside, and we can distribute it to both of the exponents, of both of the factors inside. So it goes to the 3 and to the negative 9, and when we do that, we are multiplying. So it's x to the 12th, y to the negative 36. Wait a minute. We don't like negative exponents around here, so x to the 12th over y to the positive 36th, and that's done. Each variable is only written once, no negative exponents. Great. Now, this one throws students off a bit. There are actually 3 factors inside of parentheses here. We see the x, we see the y, but maybe you kind of just lumped that 3 in with either the x or the y. So we have to distribute it to these 2 exponents, but we also have to distribute it to the 3. Not 3 times 5, but the 5 distributes to the exponent of the 3. What's the exponent of the 3? We didn't even write an exponent. I don't see an exponent. Remember, we don't write an exponent of a 1. So this is really 3 to the first power out here. And so we're going to have to take this 5 and distribute it to the exponent of 1. So there was 3 factors inside. The 5 outside is going to distribute to the exponent of each of those 3 factors. So 3 to the 5th. X to the negative 4 times 5 is negative 20. And y to the 2 times 5 is y to the 10th. Whew. Can't leave negative exponents, we know that. So let's go ahead and move things around to make them all happy and positive. We have 3 to the 5th will stay, y to the 10th will stay, the x to the negative 20 moves down south, and it becomes positive as x to the 20th. Yay, that's all done. Terrific. All right, the fun just continues. We have a negative 4 exponent outside. How many factors do we have inside? Well, I see the x, I see the y, I see a z. Don't forget the 2. There are actually 4 factors inside of parentheses here. Let's maybe do some color coding here so we can see them all. All right, look at this. I've got 4 wonderful colors there. There's our 4 factors. So some of the exponents were written already, but not all of them. The 2 had an exponent of 1. The z had an exponent of 1 as well. So now it's time to go ahead and distribute this negative 4. All right, so that's going to give us, we'll show how they're all connected there. So it's going to give us 2 to the negative 4, negative 4 there, x to the negative 24th, y to the negative 2 times negative 4 is positive 8, and z to the 1 times negative 4 is negative 4. Okay, we got lots of negative exponents. We got to move them all around. All right, let's throw a fraction line out there, and staying on top is just the y to the 8th. It's the only positive exponent. Everybody else has to move down south. 2 to the 4th, x to the 24th, and z to the 4th. They're all positive now. The last thing we want to do is we can evaluate 2 to the 4th. That's within our scope of abilities here. So y to the 8th up top, 2 to the 4th is 16, x to the 24th, z to the 4th. Hey, we have all the coefficients simplified. We have each variable once, no negative exponents. We are done. Terrific. Hey, we did problems like this way back at the beginning when we were just thinking of what does an exponent mean. So this means 3/5 times 3/5 times 3/5. And that's what we were doing earlier in this unit, is just multiplying like this. But we could apply the power of powers property and realize that this is 3 to the 3rd over 5 to the 3rd. So it kind of convinces us in a new way of what this is going to represent. 3 to the 3rd over 5 to the 3rd. Well, we can simplify that as 27 over 125. Terrific. All right, look at this fun example. We have so many things to distribute this 5 to. Now, there's a couple different ways we could go about this. We could simplify things inside of the parentheses first, or we could use the power of powers property and distribute this 5 first. I'll show this example one way and the next example using kind of the reverse strategy. So this time, let's just stick with the power of powers property and take this 5 and just distribute it all over the place. This is going to be a blast. So the 5 here, we're going to distribute it to 3 terms in the numerator and, well, not 3 terms, 3 factors in the numerator, 3 factors in the denominator. Now, when we distribute it to this 2, the 2 is really negative, and so probably best to just group this as negative 2 in parentheses. So it's going to go to the 1 exponent, the 5 exponent, the 4 exponent. It's also going to go to the 1 exponent of the 3, the 6 down there, and the 3 down there. Whoo-wee! A lot of work for that 5 out there. So it's negative 2. Don't forget my parentheses. Go back, get my parentheses. X to the 25th, y to the 20th, over 3 to the 5th, y to the 30th, x to the 15th. There it goes. So we now have that exponent on the outside is all done, but we have some simplifying that we can still do. So still some choices about the order of where we want to do things. We could just make this negative 32 because negative 2 times itself 5 times is negative 32. We have x's in 2 places, more x's in the numerator, so that's just 10 because 25 minus 15 is 10. If we look at the y's, we realize there's more y's in the denominator, so let's head down there. I'm just going to leave 3 to the 5th. That's pretty big. If you want to go ahead and expand 3 to the 5th, that's good. Good for you. And then our y's, it's going to be just the 10th power as well. And that's all the way simplified. No more we can do on that example. We have one variable of x, one variable of y, and our coefficients have been simplified all the way, and there's no negative exponents left. So that tells us we are done. Terrific. Well, we should do at least another one of those. That was a lot of fun. This time, instead of applying the negative 6 exponent right away, let's go ahead and simplify some things on the inside here. So, I see some negative exponents, lots of negative exponents in fact. We also see a 4 and a 6, which are a fraction, so we can reduce that as 2 over 3. Terrific. Then we can go ahead and play the move the negative exponent game. So that's going to be x to the 5th down here. Let's cross it off so we don't lose track of what we did. Y to the 2nd down here and cross it off. Y to the 7th up top. And x to the 2nd stays down on the bottom. And we still have a negative 6 outside. Okay. We still have some more work that we can do on the inside. 2 and 3 stay there. We have x to the 7th if we add those exponents together because they're a product of each other. And we have a y to the 7th over y to the 2nd, which is y to the 5th. And we have all of this to the negative 6th. Okay, so we still have a couple of choices. We could distribute this negative 6 to everything right now. That's one option. Another option we could do is if we didn't want to distribute the negative 6 to everything because it's negative and it's going to make everything negative and then we're going to have to flip everything, we could flip it right now. I'm going to put the 3x to the 7th up top and the 2y to the 5th down below. If I took the reciprocal of what we had, now that negative 6 is going to become a positive 6. Hey, that's going to be a little bit nicer. We'll get rid of our negative exponent steps there. So that's definitely an option for us. All right, this 6 exponent, we're finally ready to distribute it. To the 3 makes it 3 to the 6th. To the x makes it x to the 42nd. Over 2 to the 6th and y to the 30th. Wow. 3 to the 6th, x to the 42nd, over, we can do 2 to the 6th and get 64y to the 30th, and that is good to go. Terrific. Wow. Thanks for going through all of these very tricky examples with me. I hope this helped you to understand the power of powers property and how it combines with some of the other properties. Thanks again. Bye.